Okay, so this is our exam review. It's the, as you can see at the top, the old June 2009 exam that we're going through. I'll just go through the answer key is on my website as well, so if you go under at mrmundsclass.50spaces.com, if you go on there, you look under F&R assignments, I believe, then the solutions, this is there. Okay? But I'm going to go through the solutions with some explanation at the same time here on the video. All right, so the first one, we have an exponential that we're graphing here. Really quickly, the end number here gives us our horizontal asymptote. So that's +1, so there's my horizontal asymptote along here. And y equals 1. So there's my horizontal asymptote. The next part, I want to figure out my y-intercept. My y-intercept I get by plugging in 0 for x. So that's 3 onto 2 to the exponent of 0 plus 1. Well, anything to the exponent of 0 is 1, so this becomes 1. So I have 3 times 1, which is 3, plus 1 is 4. So my y-intercept is at 4. So what? 1, 2, 3, 4. There's my y-intercept. Next, I have to determine whether it's exponential growth or exponential decay. The number with the exponent on it tells you that. Anything larger than 1, it's growth. Anything less than 1, it's decay. My number is 2, so larger than 1, so I have exponential growth. So I show a function like this. Now we're going to fill in our table. Y-intercept, we just calculated is 4. The equation of my horizontal asymptote, so the value that the function will approach but not cross, that's y equals 1. The domain refers to x, so you say what can x be or what can it not be? Well, there's no value that x is not allowed to be, so x is allowed to be any real number. The range refers to my y. All of my y values are above 1. I'll never have anything below 1. And my function will approach 1, but never actually reach it. So I can say that my y is going to be greater than 1. All my y's are going to be greater than 1. And then you also have to say that other than that restriction, my y is allowed to be any real number. The x-intercept, that's almost like a trick question, so to speak. Not really. It's a really easy question. Really, if you look at your x-axis, say where does the function intercept it, or where does the function cross it? Well, it never does. So there are none. All right, next question. Write the following equation in transformational form. So that's where we're going to be completing the square. First step in completing the square is we take the n number to the other side. Y subtract 2 equals 5x squared minus 10x. Next, we want to factor out the number in front of our x squared. So we have y minus 2 equals 5x squared. Now remember, I have a minus 10 here. I have to reduce this in order to take the 5 out of this as well. Leave the blank, the square. Okay, so now that I have the blank for completing the square, to actually complete the square, we take 1/2 of this value and then square it. So half of -2 is -1. -1 squared is a +1. So we're going to +1. Now, you have to actually balance this because I artificially put a 1 over it here that wasn't here. In fact, I put 5 ones here that weren't there before. So I have to balance this out by adding 5 ones on this side. When I do that, I end up with 5 ones is 5, so -2 plus 5 is going to give me +3. Now I can write this. The whole purpose of completing the square is to be able to write this it's x times, or x plus something, or x minus something squared. It's just half of your -2, so -1. If you multiply this out, you can get this back. Finally, once in transformational form, I can go either standard or transformational form from here. So for transformational form, your vertical stretch comes to the other side, and you get 1/5 y plus 3 equals x minus 1 squared. On to number 3. Here's our triangle. The first thing it wants is the length of PQ. And we've got a very nice, easy setup for our cosine line where I have side, angle, side. And I like to relabel it A, B, C, just because that's how formulas work. You don't really need to, but that's the way I like to do it. So I'm defining side B, this is side A, this is side C. I use my cosine law for side B, so B squared equals A squared plus C squared, subtract 2AC cos B. Fill in your values. B squared equals, my A is 15, so 15 squared plus, my C is 24, so 24 squared minus 2, 15 to 24, to the cos of my angle, which is 93. So I end up with B squared equals, so here's where we go to our calculator. On. All right, I like to do this part first, so 2 times 15 times 24 times the cos of 93. It should give us a negative number, which it does. I know it's going to be negative because we're taking the cosine of an angle larger than 93. So now I can go 15 squared plus 4 squared, subtract my answer. And I get 838.7. 838.7. So I don't want what A squared is, I want what just B is. I want to take the square root of that, and so I take the square root of my answer, and I get 29. So there's the length for B. Now, get rid of that. Here was 29. Now I need the area. So you use your area formula. Now the only angle I know is B. So I'm going to use the formula that has sine B in it. Right? And my formula with sine B in it is A times C times sine B over 2. Okay. So now, fill that in. A is 15, my C is 24, the sine of my angle B, which is 93 degrees, divided by 2. Plug that on your calculator. So, when I do that, it's off 15 times 4 times sine of 93, enter. Notice I do this and I don't go divide by 2 on the very end. The calculator doesn't know order of operations. It would just divide the sine of 93 by 2, and your answer here would be much larger than what it's supposed to be. So now I'm going to take that answer, divide it by 2, hit enter, and I get 179.75. So I'll just round that to 180. So my answer is 180 over 4. Okay, solve for x. These ones are pretty quick. When I've got any base with an exponent equaling another base with an exponent on it, I need the bases both to be the same for it to set them equal. So the only base that's common in both 8 and 32 is 2. So 8 we replace with 2 cubed, power of 2x plus 1. And then 32 is 2 to the exponent of 5, all of the x minus 3. Now I've got the power of powers rule on both sides, which says I have to multiply these together and then these together. So I end up with 2 to the exponent of 6x plus 3, and then 2 exponent of 5x minus 15. Now that the bases are the same, I can set the exponents equal to one another, because the only way these will be equal is if my exponents are the same. So therefore, 6x plus 3 must equal 5x minus 15. Solve for x, take x to the other side. Subtract 3 from both sides. X equals negative 18.
Oh, how you doing?
Good. I was wondering if you could do that.
Oh, sure, yeah, no
You're
problem.
taking some stuff.
Oh, sure, yeah.
Very
I'll
good.
just change it this one because it is for it too.
Okay.
Back to copy.
Okay.
So, yeah.
I'll probably
Can't talk tonight, right?
Okay, I'll catch you before I leave.
Cool. Thanks,
Perfect,
man.
thank you.
Sorry, bye.
No problem. All right, one more. So here we have quadratic. These are the most common types of quadratics for exam questions where you've got a real life situation. They're asked about maximum height or maximum time that a maximum occurs. And part A says how long has the rocket been in the air? So for that, we're looking for how long in total has it been in the air. So we need to know what time did it start and what time did it end. Well, it obviously started at time 0, and then here's the time that it ended. Well, the time that it ended is one of the roots of my function. Right? So the other root is down here. The other root, when I actually use my equation, won't make any sense. Now, if I do my quadratic equation for this, I'm going to get two numbers. One of them is going to be negative, which doesn't make any sense for time. And the other one's going to be the actual amount of time that the rocket's been in the air. So to get your roots, there's a couple of different ways to do it. You can either factor by decomposition, or you can use the quadratic formula. Now, if I use the quadratic formula, right, we're going to plug in x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. If you factor by decomposition, you're going to say it's negative 5t squared. I need two numbers in the middle that add up to negative 30, negative 5 times 6, so negative 30, but add to a plus 13. Right, well, that would be plus 15t minus 2t plus 6. Factor that all out. Negative 5 can be taken out of that, and I'll have t plus 3. I can take a negative 2 out of this, and I'll have t, that should be minus 3, t minus 3, t minus 3 over here. And you get that it factors to a negative 5t minus 2 to t minus 3. So we say, well, this has to be 0, my height, time, so when can this equal 0? Well, we solve for this one, and you get that t would equal, let's see, negative 2/5, or t here is equal to positive 3. Well, again, a negative time for root doesn't make sense, so we report only here. So at 3 seconds. After 3 seconds, the rocket comes down. So total time in the air was 3 seconds. The next part, the maximum height. The maximum height occurs right here at the vertex. And we've got the nice easy formula, negative b over 2a, gives us the x of the vertex, or in this case the t for the vertex. So plug in the time for the max, and it's equal to negative b, so negative 13 divided by 2a, so 2 on to negative 5. So my t max occurs at 1.3 seconds. To get the actual maximum height, plug in 1.3 for my times. Negative 5 onto 1.3 squared plus 13 onto 1.3 plus 6. So my max height. And go back to our calculator. So go negative 5 times 3 squared plus 13 times 3 plus 6. 14.4. There it is. So there's the first half of the review, and I'll get questions 6 through 10 in the next video.